Sorry, I was a little bit late. Let's just wait a couple more, maybe. Hi, Claire. So, hey. Today we're gonna try something new, but before that, I got some kind of general stuff to say. First, as Abhi said, it's gonna be a closed book, so the question is gonna be similar to midterm 3. So there's no elevation on the difficulty, so I kind of expect Abhi to give the similar questions, so we can hope for the same definition questions maybe. But probably kind of this time there's like limitation on the words used or characters, so which may just ask you to briefly define those terms. We can have a hope on this kind of simple questions to be appeared. So I guess probably similar. Both Abhi's part and Joanne's part is gonna be equally weighted, like last time, and probably Joanne gonna send us her questions. If she got more than one structured questions, we might just choose one of them. Then plus Abhi's short answer questions, namely the definition question, I guess, because they haven't shown me the draft till now. So that's what I expected to do. So to have. So today, I might need to have a focus on Joanne's part first. We'll have a hands-on summary, so I'm gonna write it down something. So also help you rationalize some terms, and also give you the idea of the overall flow. Okay, we have 12 minus 1, which is me. Oh, and this video gonna be uploaded later, so you can always jump back to the same link, I guess, to replay. So now let's dive deeply into our materials. Will we have any final practice? Okay, I can ask Abhi. Yeah, that's a good question. Or I can try to find if I have the past exams. Yeah, I will drop him an email to see if there are any practice questions for his part. But ideally, I hope he's giving the definition question. So, which is actually the 3 points for you guys. Okay, let's try something new. Let's see if this is gonna be better. Okay, it's gonna be really weird for me to write down something, but okay, for this one, lecture 22. We talk about the overall transport, the transport, that's like ADME, but here definitely we talk about something about distribution. Oh, the focus is not good. Okay, that's better. So here, two things that we want to differentiate. One is paracellular transport, and one is transcellular. So, well, you guys definitely has better English than me, so I don't need to define. Para is a prefix for for like along with something, so it just go through those gap, while trans means like going through the cells. So here, remember, there are some examples we want to know. These like gut wall, liver, and kidney tubules, and blood, the BBB, they're majority transcellular. So talk about paracellular. This example you should know, which we talk about this later in the later lecture, which is glomerular filtration, and later we have GFR, the filtration rate. So for sure, this is down the gradient. This is down the gradient, so that's independent of lipophilicity, charge, and size, because you don't need to contact with the cell membrane. You just go go into the gap between. So that's why the protein-bound drugs do not pass. That's why we have this GFR with proportion to the fraction unbound, because the protein bound will not go through this pathway. So in the in the cellular transport, there are passive diffusion and facilitated transport. So passive diffusion is also down the gradient. But later, with the facilitate transport, we also have two different kinds we're going to talk about. Yeah, sorry. That's maybe now is a little bit better position. Okay, cool. So the rate of the passive equation gives up the idea like the GC equals to P times SA sorry. Okay, so GC equals to P times SA times the difference in concentration. It is a good idea that you can memorize this equation with their unit, but I don't think she will ask any question about the unit. It's kind of a naive question, but it will be a really good idea because you want to know the rate is actually the number of molecules per time unit. So this one is area, so it's meter square or centimeter square, and this is a concentration. So you can kind of rationalize what the unit of this P. So we have encountered this questions in our practice that what affect this P, this permeability coefficient. So again, you need to memorize. Well, this is something that you don't need to memorize, but you can rationalize by yourself. For sure, the P equals to the KD. That is like K times D divided by delta X. Well, we forgot about what delta X because it's the general the thickness of the membrane. So the key is the partition coefficient, which is like how like they're saying called like dissolve like. So we want to know like how close the drug and the membrane, like how likely the drug and membrane gonna be in terms of their lipophilicity. So this is the term measure the lipophilicity, and the diffusion coefficient is like how hard this drug go into the membrane. So it's like you're pushing something into the sand or something. Into water, into gel, into whatever stuff. So it is a matter of both partners. It's the membrane viscosity and the size of the molecule. So we have this. So for sure, the size gonna affect the diffusion coefficient. Or here we use molecular weight because for in terms of size, it might be something about the radii, but we're not expecting all those stuff to be globular. So we just in terms of the molecular weight. So molecular weight affect D, and lipophilicity affect K, so that's log P, and charge and polarity also affect P, so the charge and the polarity. So for this, you just need to first get. Okay. So for this, as I said, you should know that if the log P is negative, then that means favors water. And if that's positive, then that's favor organic solvent or organic. So that's more lipophilic. So for pH, this equation, I can help you derive how, I can give you the idea how this equation was derived, but it's not important, but it just helps you understand. So we know for a general molecule, say H, try not to be confused with HA or HB, either acid or base, or let's say HC, whatever. So it goes to H plus C. So definitely this is a plus charge. The protein has a plus charge. So we don't care about this gonna be a total plus or nothing, or this gonna be a neutral or minus. So just have this. So the pKa, oh sorry, the Ka is actually the dissociation constant. So it's just like H times C divided by HC, so it's just like KD stuff. Something. So P means minus log. So if we all take P, which is minus log, then we have pKa equals to, so if you take minus log of H plus, then that's pH. So pH minus log C over HC. So if we move this to this side, you will have pH equals to pK plus log C over HC. So in all cases, the one with H is always, you can memorize this general equation. So the one with H is always in the, well, this is called denominator, or I forgot. So which is also at the bottom. Then if that's the case, if say HC, if that's HA, then you have the ionized form on top. But if that's HB plus, then you got the ionized form at the bottom. So this kind of help you if you cannot remember. Sometimes you confuse with the plus or minus. This is a way that you can try to rationalize by yourself. I hope there's definitely enough time if you just have time to double check your answer, and you just not that sure about which equation you use. That's a way to do it. So the next slide said, this is one of the conclusion that you should. So the assumption is that the pH partition hypothesis, the hypothesis that only unionized form can occur finally at the equilibrium. So that's the conclusion. So because their unionized form are at equilibrium, so definitely the side with greater ionized form will have the higher total concentration because they all plus the same ionized concentration for both sides. So that's the overall. Oh, okay. So yeah, here we went through. We can jump this. So now when talk about the carrier-mediated transport, there are three features. So one is they're specific, so because they have a structure rather than just a membrane and the gap. And so that they can be inhibited and they can be saturated. So the saturated will have the, so that's the case. If we go back to the passive diffusion, we have this one proportional to the C, and so that's gonna be linear. But here, if we consider something happened, say drug plus transporter to drug transporter and further to transporter plus drug outside somewhere. So this entire process is like what we've gone through before, the enzymatic process. So it has the Michaelis-Menten kinetic. So that's why they have the Vmax, which is all the transporter were bound, and so on and so forth. So here, the facilitated transport also has two versions, which is called facilitative and active. So facilitative is something like passive, it's also down the gradient, but there is just a gate, like the transporter gate, to help those like larger protein or something to go through, while the active transporter can go against the gradient. So now we have three kinds of transportation: the paracellular, the passive transportation, and the facilitative transportation. So all three are down the concentration gradient. So the only exception we went through lecture is the active transporters. So yeah, and then the last slide, same porters is same direction, antipoders different direction. So this is quite straightforward. So then in lecture 23, we discussed something So lecture 23, we talk about PGP. Then 24, 25, we talk about the liver clearance and the renal clearance. So PGP is one of the, so here, as I said, this PGP is an active transporter. So okay, let me change the other side and try to get into the focus. So I won't go through this, but just make sure that the SCL, which is later all those organic, what is that? Organic anion, like OATP stuff, they are SLC transporter. So their majority of them is try to get those things into the cell, which is uptake or influx. They can be both facilitative and active, but for PGP we talked about here, that's all the ABCs are all active. So they function as efflux, which is sort of pumping the drug out of the cell. So okay, we're gonna skip that. So these are those transporters we discussed. We discussed in detail later. So in this slide, they summarize what we're gonna go through in detail. So something about the mechanism, like the drug disposition, and some mechanism of how we got some toxic effect. And drug-drug interaction is just like something you inhibit the transporter, and the other drug will then have a decreased clearance, so they might be function more efficiently. Then also these are all about those stuff. Oh, okay, yeah. This one, the individual variability in drug response can reflect to something about the polymorphism, which we're gonna talk about later. So here is the key slide of the entire lecture, and where those questions could arise from. So this is the key slides of the lecture. We have, so if we have the cell, and where this is the blood vessels and this is lumen. So oops. Actually, you gotta focus. So the PGP transporter is sit on this side, on the lumen side, to get things out of the cell to the lumen. So in this case, so if this is got this GI tract, so the way is that to get your drug molecule to the lumen, back to your stomach or intestine. So if for oral absorption, you will have, let's say here, PGP. For oral absorption, you will have reduced oral absorption, which is equal to oral AUC, area under the curve, and also the bioavailability. So that's if that's gut. So if that's liver or kidney, basically you get the drugs from the cell to the lumen, so you increase the clearance, which is the secretion that's equivalent to decrease the IV AUC, or the drug level in the blood. And then for either BBB or placenta, so you just basically try to get the drug back to the blood, back to your body, not going to those specific area. So that's the special cases. So that's the thing. In general, if you induce PGP, where we have the example of rifampin, then you will get all this effect increased. I mean, it's like decrease and decrease more, like increase and increase more to a larger extent. But generally, like, on the other hand, if you inhibit PGP, then you will got the reverse effect, or you mitigate all those effect that PGP can bring. So yeah, that's logic, right? So here, for all those drug-drug interaction we discussed, or even if you see any new pair of drug-drug interaction pairs in the exam, one thing I really encourage you guys to do is that you have to try to specify which one is the PGP or transporter substrate, and which one is its inhibitor or inducer. So is the inhibitor or inducer working on the PGP or other transporter, and which give the effect on the drug, which are their substrate. So simply here, when you have the inhibitor, you just kind of mitigate all this effect, so you will minimize the renal clearance or liver clearance, or increase for oral administration drug, you will increase their oral AUC and IV AUC. So that's the inhibitor. Yes, that's the inhibitor. So for the induction, you will kind of decrease this AUC. So then talk about blood-brain barrier here. It might be a little bit confusing that. So that's why in our practice question, when the question asks, regardless of the active transporter, basically you shut down this arrow. So what you compared is just the transportation through simple diffusion and facilitated diffusion. So that's actually, the passive diffusion relies on is lipophilicity. So that's why the more lipophilic drug has the better permeability. But if we take this into consideration, if we take the active efflux, the transporter into consideration, then the unbound drug. So the fraction unbound gonna be important, because the more you have bound to the transporter, then the more you will get rid of that back to the blood from the brain cell. And yeah, so do notice there are another pair, which is this one is a PGP inhibitor, and this one is the substrate. But this one does not. This one is not the case for the drug clearance, but this one is the case for how to get this drug into across the blood-brain barrier. Then 24. Okay, 24, we talk about the hepatocytes. So lecture 24. In the focus of OATPs, which is a influx transporter, that's actually lumen blood OATP. So that's always on this side to try to get something in. But the overall effect in terms of drug clearance is same to the PGP, because you are always getting drug from the blood into the lumen. So one is extract drug from the blood, the other one is from the cell into the lumen. So you're gonna expect them to have the similar effect on the drug clearance stuff, like the one I talked before. So here in this slide, I think you need to know the substrate of OATP. Here we emphasize the statins, and the inhibitors, which we talked about this one, and some HIV protease inhibitors, whatever end with like wire, something that work on the retrovirus, and also rifampin. So this work on both influx and so this is inducer. So this no. So this is an inhibitor or inducer. Yeah, I guess this is the inhibitor of this one, but an inducer of the efflux. So here we have the study on the statin, which is substrate. And when you have this drug as a inhibitor, you inhibit the transporter to get this drug from the blood, so you will have higher AUC. And these talk about the genetic polymorphism, as I said before. So just make sure that also you have the logic here is that when you have weaker activity, which is something like you inhibit the transporter. So when you have weaker activity polymorphs, so you will have a larger AUC. So make sure that if there is a question that give you the curve and ask you to select the correct one, do have this in mind, that if you have the weaker polymorphs, you will have a higher AUC, you will lower the clearance, and you will have a higher substrate AUC. So you have a enhanced or stronger, you will have more clearance, so you have lower AUC. Okay, lecture 25. So mainly we go through the renal clearance. So 3 steps: glomerular filtration, which is you should know, which is the paracellular transport, and tubular secretion and tubular reabsorption. And the reabsorption is actually mainly through the passive diffusion. So you might need to remember this number because we have that kind of practice question, and she didn't provide you with the number for normal healthy people, for normal healthy adult. So probably you need to memorize this in your brain, that that's a healthy glomerular filtration rate, GFR. So since this is para, so it has a threshold for the size, and all those bound drug to the protein bound drug cannot be filtrated. And this is just a simple math. That what's more important you should know is these conclusion. So after the filtration, there are secretion and reabsorption. So if the total clearance larger than the filtration, larger than the amount passed through the filtration, So you could expect, or you could hope that there are more secretion. But if that's lower, so it must be the drug will be reabsorbed through the reabsorption. So I kind of imagine maybe here like retard alert that there might be a possibility of having a calculation question as a structured question, like short answer question, like here, and then ask you one of the conclusion, which one is true, or maybe that's in one multiple choice question that asks you which conclusion is true. So here, bear in mind, for the organic anions, which is from the weak acid, because you can imagine all those acids gonna be dissociated to a proton plus, and proton is plus charge, so so the other part gonna be an anion. So weak acids give you organic anions, and weak bases give you organic cations. So do you recall our Henderson-Hassenbalch equation? And remember the difference. So all OATs, they are for renal clearance, and OATPs, something peptides, are for the liver clearance. So they are a little bit different on their target. So the liver one is usually larger and more hydrophobic, while the one for renal clearance is usually smaller, and usually have charge, like 1 to 2 charge, or like it's like small and more hydrophilic. So that's the difference, and this difference also true for the OC, the organic cations. So here we have this case study that you should know. Well, so the substrate here is actually beta lactase. Well, how to spell beta lactase anyway, or penicillin. And the inhibitor here, or the one that has effect on the transporter, is either PAH, which is the older form, or the Obrancid. So here, yes. So for the subject, you might need to know that the beta-lactam NSAIDs and antiviral drugs, again, like those that end with var, they are all the substrate, and they will all be affected by this drug, which is the inhibitor. So here kind of we rationale the thing. So here we know for this it's gonna be similar. This is blood, this is lumen. That this transporter is actually here from blood into lumen. So do remember here we call this a nephroprotective agent, so it can reduce the nephrotoxicity by the mechanism here. We know this is for the excretion, so you have something from the blood, you have the drug that that's the remaining drugs after the filtration in the blood, and they try to go through this to the lumen, but if it works like this, when this drug go into here, but the lumen has a slow flow rate, these drugs can actually kind of accumulated in the kidney cell, which cause nephrotoxicity. But if we inhibited this pathway, so more drug will go through this, will still in the blood. So the effect is that you still have the AUC in the blood increase. You got decrease in the renal clearance, and because there are less drug accumulated here, so you will have the decrease of the toxicity of the kidney cells. So that's how we rationale these two, which is the using of probenecid with the effect of those drugs like beta-lactam and those antiviral drugs. So here, similar for OC, we have the same criterion. They should be small and hydrophilic to be cleared through renal clearance. Otherwise, if they are large and lipophilic, so we can imagine most of them are cleared by liver, because maybe you can connect this idea with our second part, because those large and lipophilic stuff, they probably have to go through the metabolism, because they are lipophilic. You want to have those modification to make that hydrophobic into the lumen and excreted. So those lipophilic drugs there are more portion of those are cleared by the liver, then smaller or more hydrophilic ones gonna be in the renal one. So there are another pair of drug. So then this is the substrate, because the clearance of this drug was either higher or lower. So this is a substrate. This is the one that that been taken effect on, and this gonna be the drug used to inhibit the transporter. So I'm not so sure, but I don't think she requires you to memorize all those drug names, but I'm not so sure about this because I haven't taken that class. But there should be the way you can tell from the description of the question if you read that carefully. Definitely, I will double check before Monday, so to make sure that there's no uncleared question or unclear description of that question. So here, similar. So this toxicity happen when these drugs, these are the anti-cancer drugs, accumulated in the kidney cell, because they have more from the blood to the cell. They have faster rate from the blood to the cell than to the lumen. The reabsorption, so because that's passive reabsorption, so which is like something we talked about the blood-brain barrier. Mostly those lipophilic drugs can, because it's passive, so they have better membrane permeability. So bear this in mind, and also this in mind. That's the cause of the nephrotoxicity, which, and also the driving force of the reabsorption is the lower rate, kind of equivalently concentrated drug. So we know that passive transportation is also considered the difference in concentration. And also this affect the permeability. So both these two affect the reabsorption rate. And also, because we talk about pH, so this is a case that I actually discussed beforehSo because the idea is that only unionized drug can go through so if we have the weak base, so for the weak base, we know that in low pH, or high pH, in low pH, they tend to gain the proton, and in high pH, they tend to lose the proton. So for weak base, in low pH, they gain this proton, so it becomes plus charge, and in high pH, they lose that proton, so they become the molecule itself, so it's zero. So for weak acid, in lower pH, that's zero because they get this proton, and in high pH, they lose that proton, so become minus. So this could explain this graph. So for this, which is the weak base, This is like weak. So this is like low pH. So majority of them are in acidic form. Sorry, not in like a charged form. So they cannot go through the passive absorption efficiently. So you will have this excreted, so you will have a larger clearance because they stay in the lumen, they cannot reabsorb into the blood. So this curve gonna be reversed if this is the acid, because acid gonna have like acid should change this curve. Like this one should be high pH and this one should be low pH. So that's all the points. Probably I went through this quite fast. But you still have 2 days that you can find your way how to use my my words as a reference to review. Then for Abhi's part, I won't write down this stuff because I kind of have the feeling that he might be given this definition question. So I just want to know that which definitions are important, like I think are important for you. So I'm gonna close this. Based on the previous exams, definitely his definition questions are given from those concepts that he emphasized. So in this one, I mean, I don't want to let you go through all these slides. Still, you may need to memorize those drugs as he indicated, but I guess from the last exam, he should have like 5 to 7 MCQs, so he might not test extensively on those drug names or stuff, but you should have the idea what is that drug for. Like here, also the statins, we also talked about here. So we don't miss this in the test. So don't mix up this. Like here we have the statin for the steroid synthesis, but we also have the statins that was in the transporter side, transporter lecture. So also kind of this drug might be important. This one, there's no important concept, but the entire idea is kind of talking about something that was anti-inflammation and platelet. Yeah, but do memorize the aspirin is an irreversible inactivator. Yeah, I don't think any very important concept here in this lecture, but this is an important one because antibodies also, this has a lot of concept. Make sure that you can tell the difference between the innate immunity and adaptive immunity, but most we talked later are the adaptive immunity. So if they're saying something with the antibodies, it's happening with antibodies with like T cell dependent signal, T cell dependent CD4 or something, those are definitely adaptive immunity. I won't go through this. And his part is really clear. Okay, here, because most of cases when we talk about the antibodies, we talk about IgG related. So do notice that there are two light chains, two heavy chains. These are variable regions, and this is a constant region. So this is called Fab. So if you click from this hinge, so this one is Fab, and if you click on here, this one is Fab. So this is Fc domain, and only Fab has that hypervariable loop. So all these constant region are really stable. In sequence, but this is called constant region. But later we'll see that the constant region has 3 domains, but the variable region is just one domain. I guess this is really important. So I really want you to remember this, because we know that the function of IgG is to kind of recognize and kill those toxin or viral stuff. So these are the mechanism that how IgG works. So it might be both important in multiple choice questions and the definition questions. So maybe ask you what is neutralization, or what is agglutination, and you should be able to differentiate all these mechanisms. So neutralization is just to bind that and block them to interact with their target, and this one's actually coagulate agglutinate some through this Y-shaped IgG because it's bivalent. So that's how we appreciate the bivalent. So similarly, if you say instead of IgG, if we use Fab, it does not affect much on the neutralization, but definitely this won't be happen, and this won't be happen, because you don't have Fc domain. ADCC won't be happen because all those require Fc domain to be recognized by further stuff won't happen because you don't have Fc domain, or all those require the bivalence, like this and this, won't happen because the Fab is monovalent, is univalent. IgM, I don't know. Maybe you should know that's the first line of defense. So usually the B cell secrete IgM first to have a rough idea that what the target look like. Then IgG could have those like through the VDJ, those hypervariable loop could mutated and went through the affinity maturation to have the better binding affinity with better binding event and neutralizing whatever with the target, with the antigen. So here, again, this one's important. You should know if he uses something IgG or bispecific antibody or Fab or SCFA, which is just, as I said, you'll see this is a variable. This is a variable region and also variable domain, but this is constant region, but they have 1, 2, 3, 3 constant domains. So here you have one variable, one constant, but here you just have one variable. So be careful about all this. So here's a case study. You know better than me on this, because in the class I saw someone said Humira. Okay, so here comes this. This may be a important idea or concept that easily asks you the question to ask you to illustrate. This may be in a multiple choice questions, because I kind of have seen such a question in the past exams. If you still remember, there are some questions in your first part, like he uploaded some past exam questions, but some questions are actually related to antibody parts. I will double check that. So probably you can find some practice questions in that folder, in the past exam folder for your midterm 1. I remember I saw some, but I'm not so sure. This may be in the multiple choice questions. Is quite straightforward, easy, and yeah, and direct, straightforward. The T cell receptor, you should know it. So the T cell receptor has something similar. It has a hypovariable loop, something similar to the Fab. But this is a T cell, and the Fab is the part of IgG secreted by B cell. So both B cell and T cells have something like a mechanism, like similar mechanism against the antigen, but the difference that this is like for the intracellular toxin something within the cell, but that one, the secreted antibody is the B cell secreted that to find those target on the cell membrane or outside the cells. This is example, but it's actually a quite simple idea. Yeah, he won't ask this. I don't think he will ask this. Yeah, just make sure that you have gone through the key concept, especially the nomenclature. You just simply need uh, to remember those few letters, and if there's a question, you will just quickly answer that, direct and fast. These two, there are some okay, like, oh, not this one, but wait a second. Yeah. So here, GCSF, there are different form. So this one with pack, this one without pack. So with pack, a prolonged, because it cannot be cleared. Um, it cannot be cleared randomly. So a prolonged, it's AUC in blood. And compared to the others, all the E. coli expressed have no glycosylation or other post-translational modification. Those expressed in the mammalian cells has the glycosylation. So we come into the similar idea later, which is also one is for the, this is something for the insulin stuff. No, I mean we'll talk about later. So also those two examples, one is expressed in E. coli, the other one in mammalian cells. Okay, here, this one highlight here might be a important concept that you should know, which is also very quite straightforward. It just maintain the balance between coagulation and anticoagulation, or bleeding or clotting. I don't think he might ask something about all those pathways, but just to memorize this concept, and skip this, and also here this concept, feedback activation. Or if there's a question like why we choose thrombin or this 10A as a target, because they kind of all these pathways converge into this one, and this is gonna be unique, and this also has activate this some molecules that can have the feedback, the positive feedback effect in the previous in the upstream reaction. So that's why I make this a better target. So I guess that's the point about this graph. You don't need to memorize all these stuff. Just the core idea is about feedback activation and why we chose this target to work on. This one, I don't think he will ask question about this. It's just minor, but it's just a cool peptide drug that can actually bind both um, allosterically and also on the active site. So that's kind of a cool thing that peptide drug can do, not the simple molecular drug molecule. Okay, so this is the another. Oh yeah, it's about. Sorry, it's not about insulin. It's about the clotting thing. So this to the TPA. Also, you should know the difference. One is glycosylated because that's expressed in the mammalian cell, and this one, the threaded place, is expressed in E. coli. So it's actually smaller, so it can kind of, for some reason, be less targeted for the clearance and has a longer half-life. So that's also the difference between these two drugs. Peptide hormones, insulin. He might have a multiple choice questions because I don't think there's any highlighted or conceptual thing that you can explain, but make sure there's a monomer. So the active form is monomer, and the inactive form is hexamer. So there are those designs or those mutations gonna be active immediately. So, and I think you guys know insulin better than me. So it should, or he didn't mention this in the slide, but he did ask you guys about what the difference between type 1 and type 2. So, and that's it. Yeah, so that's it. So for his part, I guess just make sure that you know some cool concept, some core concept in this class or in his part. I think because he mentioned this in the class, so it might be. So we might have still the same questions. I mean, similar structure of the exam. Okay, any questions? Um, Abhi said no, but um, I don't know from Dr. Wang's part. Well, because I'm guessing that Abhi just gave those definition questions. Then Dr. Wang, I don't know. But since you guys are all at home, you can use your calculator. No one said you cannot use the calculator. So, as I said, was there were some calculations in her notes, but those are really simple calculation because all those equations are actually linear. You don't need to solve for something. So yeah, so the only one possibility that I mentioned just now is about the renal clearance with the GFR. So you might have the question to calculate something, then compare and see if that's overall excretion or overall overall secretion or overall reabsorption. That might be the only. I guess that might be the only possibility of having any like meaningful calculation, rather than give you like all those drugs stats and ask you to calculate the the permeability constant or whatever. I'll maybe give you. Okay. So it might give you a ratio in the aqua phase and in the organic phase, in the octanol and water, and ask you to calculate the log P. That might be in a multiple choice question, but it's really straightforward. You just need to log that ratio. So I hope that's the similar idea that we can adopt for the midterm 3. So actually, from Edith Wang's question pool, I picked some questions. So there are really simple and direct ones, like what is the KD, and like what is this, and there are something tricky, like I know you know the occupancy model, but ask what is the effect of what will affect this model, and there are also some tricky ones. So we definitely will make sure the coverage and also the level of difficulty, so that we can cover both straightforward question and some question that you need to think about that or apply some logic to analyze that. Any more questions? So after this, I will upload this as a video, so that you can check back. You can go back and check every time you want. I hope I have covered all those important concepts and kind of my draft. I hope my draft is clear to summarize some points. So that is usually the way how I study. So I mentioned that I never make that like really neat summary, like what I did for the midterm 1 and midterm 3. Instead, I did like something like this. I just draft something, try to connect all those stuff and kind of draft something. Also, try to find something logically linked. Also, when you're writing down something, you also kind of having the muscle memory. So it's just like double. It's just like a double memorization part. Any questions? Any thoughts? Or any fun activities after the final? Oh, probably not, because we're, yeah, just suggest that not take those not unnecessary travel. Just stay healthy, everyone. Right. Limit the travel, keep social distance. And also like preparation for the P-Suite class. That one's on Tuesday? Oh, cool. Okay, yeah, I mean, this is gonna be my last TA session for this class. Theoretically, I don't need to do any TA works, but will you guys take the immunology class? Is that a core course for you guys? Still start. I think that starts with MedChem for next quarter. So that one will be lectured by my boss. So that's uh initially I was supposed to TA, but they actually scheduled me with this one this quarter. So kind of I don't need necessarily to TA for the next quarter. But I may just like walk in and listen to some lectures next. Oh no, there's no walk in, but yeah, I may just like jump into the Zoom sessions to listen to some lectures from that immunology class. Well, yeah, well, so I appreciate all of your like and your support with my work. So, um, like I did some like my self evaluation or feedback on myself. Hopefully, um, I didn't like shape you guys into the same thought. Like I'm the Chinese. That like most of the Chinese education was blamed because they kind of shape students into the same shape or same thought. So hopefully by talking to you about all of this method I take, and the way I prepare for or think about the question won't make you feel like I'm kind of giving you all those things that I ask you to do. So still try to find your own way to study, to review, and and like I said in my very beginning, like very first review session, the midterm one, it's like sometimes I ask question based on the materials, um, and some may be interesting question, and some may be just tested in the exam because that's just like naturally grow from the knowledge based on the materials in the class. Um, that might be interesting. I mean, that might be a way. Um, Also, like try to use different way to digest the knowledge. Maybe another way. Um, so although here, like I told you previously, that you should also have some test taking skills. Still, our main purposes is help you understand the idea, give you this like fundamental concepts and ideas, that can facilitate your future study. Also, but I know you guys have to take exams. You guys have class next quarter, special for your curriculum. So you will have those exams. So it's still also quite important that you have the skill and ability to handle the exam well. So that's all my thoughts. That's all my thinkings. Um, if you don't have any questions, just oh, don't worry. I thought this is my responsibility. I hope actually everyone will do well. So yeah, well, good luck for all the exams. Finger crossed. Um, Stay strong. Stay healthy. Um, yeah, stay healthy, everyone. Um, so maybe my spring break. Um, yeah, my boss just asked me to work from home, so I'm just to analyze some of my experimental data. So I might spend most of time at home too. Okay. Take your time. Um, take your time and sort of arrange the review of all the other class, and you can also ask me questions as a either as a comment here when later I upload this video, and if you find questions tomorrow, you can also um, ask me question either through email or leave the comment underneath this video. That's all fine because I had received the notification. Um, yeah, arrange your time in studying all three classes, and have a good study life balance, stay healthy, and that's a top thing. Yeah, just leave me questions or something tomorrow or even Monday morning. So I might check. Yeah, I will check with Abhi if there's also some practice questions, and I'm gonna check how he developed the online quizzes through Canvas. And that's all. That's all for today's session. It's 2 hours. Just best of luck, everyone. Bye. I'm gonna disconnect from this. Bye.